Hello and welcome back to ntraz.com. Today we're going to be looking at some pretty basic switching concepts. Now, the topology we're using is 4 separate switches with dual connectivity between each and every other switch. And one of the ways we can see which devices we are connected to is with the show CDP neighbors command. So you'll see here all of our devices have other various switches or other various routers connected to them. This gives us a good indication and understanding of the topology of our network. Now, we're starting out with basically a clean slate. The only thing we've done so far is named the devices. Switch 1, 2, 3, 4, routers 1, 2, 3, and 4. If we check out our VLANs, you'll see here that by default we only have a single VLAN and that every active interface is on this VLAN. If we do a show interface status, you'll see all these interfaces, their port IDs, and their connected status, as well as which VLAN they're in. Once again, of course, by default, everything is in VLAN 1. After we look at the CDP neighbors and the interfaces, we can do a show spanning tree for VLAN 1, and this will give us information about the bridging groups and bridging loops within a layer 2 domain. In the case of switch 1 here, you'll see that this bridge is the root. We have a priority of 32.768. I know it says 9, but we'll get to that a little later. And of course we have the lowest MAC address. We come over here and do a show spanning tree for VLAN 1. You'll also notice that the priority is the same, 32.769, and the MAC address is different. So you'll see here on this bridge ID we have a 6,000 when switch 1 has a 5,000. Now, since the priority is the same, the MAC address will determine who the root is by default. In this case, you'll see that 5,000 is less than 6,000. 5,000 is less than 7,000. And 5,000 is less than 8,000. So from here, you'll see all of our interfaces, their status, and their role. In the case of a default configuration, you'll see here that we have the designated ports that are in forwarding. Other than this interface telling us that the device is the root, having a switch with all designated ports for a particular VLAN tells us that it is the root bridge and that all traffic will flow through this device in order to make it across the network, once again depending on how our interfaces and links are configured. On these other devices, and keep in mind this is the rapid per VLAN spanning tree. So every spanning tree is going to have a VLAN instance ID, in this case VLAN 1. Real quick on that, let's see if we can find this. Show run include span. So 32.768 is the bridge priority by default. This command right here is the default in all new systems. Extend system ID. What this extend system ID adds the VLAN identifier, in this case 1, to the bridge priority that's configured. 32.768 plus 1 is 32.769. Moving on, however, you'll notice here that all these switches have a root forwarding port. That is because the root path cost, or priority number, depending on the configuration, is the quickest, lowest cost to that route. So you'll see here that on switch 2, Ethernet 0/0 will be the root port based on cost, priority, and interface ID, as well as, of course, the bridge ID. If we do a show CDP neighbors Ethernet 0/0, you'll see here that that is indeed switch 1. The second item you'll see here, show spanning tree VLAN 1, is the alternate blocking port. And Rapid Spanning Tree, they changed this from just discarding down blocked port to an alternate port, which allows us to use this alternate port in case of a failure. So Ethernet 0/0 and 0/1 on switch 2. If we do that show CDP neighbors again, you'll notice that 00 and 01 are both connected to switch 1. So this creates an alternate port. You'll also see here on other devices that have different spanning tree configurations, so to speak, you'll also notice that we have the alternate ports 0/3, 1/0, 1/1. So these ports will technically be shut down or no data will flow through them. So these links will essentially be not used. If we look at the show interface status over here on switch 3, we'll be looking at 3, 0, and 1. They're all connected, they're all up. Show CDP neighbors, and you'll see that these interfaces are still showing as a CDP entry. Now the reason for this is because CDP is still propagating because it's not blocked by the spanning tree process. So anyway, this paints an interesting picture about how spanning tree works. So one of the things I want us to do really quick is come over here and create a VLAN 2. Do show run section VLAN, and you're going to notice here that the VLANs do not show up in show run. So let's try do show run all section VLAN. And once again, you do not see them. Keep in mind that once you create VLANs, they do not show up in the running config, but a VLAN.dat file. Let's see if we can find that. There we go. So this VLAN.dat file is the configuration container for all the VLANs configured on this switch. So let's come over here, VLAN 2, same thing over here on switch 3, same thing over here on switch 4. So now we have the ability to do show spanning tree for VLAN 2. In this case, VLAN 2 does not exist. Technically, VLAN 2 does exist, however, it's not assigned to any interfaces. Remember earlier when we talked about the VLANs and the interfaces? Well, by default, VLAN 1 is the only VLAN that's allowed across all of these interfaces. So what we have to do is do an interface range command. Hopefully this will take all of them. And it did. So currently they're in an access mode. Do show interface E0/0 switch port. Hopefully this will work, and it does. So you're going to notice that we have an administrative mode of dynamic auto by default, but it's an operational mode of static access. We're doing a administrative trunking, encapsulation, and negotiate, and other various information. So from here, technically we're doing a switch port. I believe it's mode dynamic, auto, and desirable. We come back up here, you'll see that we are in dynamic auto, and we have the ability to be dynamic desirable. By changing it to desirable, it will automatically create a trunk port. Now, a lot of the times dynamic is okay, but most people don't like having devices dynamically assign anything. So if you wanted to have it an access port and only an access port, you can do the switch port mode access command and the switch port access VLAN whatever port, like VLAN 2 as an example, and that will make it VLAN 2 assigned. But what we want to do is switch port mode trunk. However, in certain versions of iOS, we have to specify the encapsulation. Switch port, trunk, encapsulation. Currently it's in negotiate or auto, but we want to use the industry standard .1q. From here, we can specify the switch port mode trunk. And we're going to do the exact same thing to all of our other devices. And you're going to see here that now we have our interfaces kind of flap. And we'll find that interface range statement. We'll copy this, we'll paste it. And from here, switch port trunk encapsulation .1q. And from here, we'll specify switch port mode trunk, SWMNT. If you want to get really fast, it's a good idea to understand some of these shortcuts. So switch port mode trunk. From here, we'll do show VLAN. You'll notice here that now we don't have any ports assigned because they are trunks. We can do a show interface trunk command to show us all of the VLANs configured, allowed and active, and of course forwarding and not pruned. In this case, you're going to notice we are allowing all VLANs 1 to 4094, but we only have 2 VLANs configured, VLAN 1 and VLAN 2. If we do show spanning tree VLAN 1, show spanning tree VLAN 2, you're going to notice it's pretty much the same, because the priority is the same, 32768 plus the system ID extension. Once again, it's 70 because we add the VLAN identifier. Now all these, of course, are designated forwarding. So if we just do a show spanning tree, it'll tell us the configuration for VLAN 1 and the configuration for VLAN 2. In this case, we might want to have another device kind of load balance all of our ports depending on configuration. So one of the cool things we can do is we come over here and do spanning tree question mark, and we have a lot of options. So spanning tree VLAN 2, we can specify the priority. Now once again, the priority was that 32768 we saw before. Specifying a lower priority will make that device a lower bridge ID and make it the root in increments of 4096. So if we wanted to use this as a root over switch 1, we can either make the bridge priority higher on switch 1, or we can lower it on switch 2. In this case, 32768 would be, I think, something like 28876. Oh, there you go. 72. Now by doing this, 28672. Now by doing this, we'll do show spanning tree for VLAN 2, and you'll notice that it is not the root anymore. Switch 2 is now the root because the priority has been lowered, and you're going to notice they're not all designated ports anymore. On switch 2, we do show spanning tree for VLAN 2, it is now the root. And all these other devices, you'll look here and see that switch 1 is the root for VLAN 1, and switch 2 is the root for VLAN 2 because we specified the priority. Now one of the other things we can do if we don't want to have a static priority is we can have a root command. Now we can specify a root primary and a root secondary. In this case, we'll just do root primary for switch 2 and a spanning tree VLAN 2 root secondary for switch 1. So we'll come over here, show spanning tree for VLAN 2. You're going to notice now that the bridge ID for the local switch has been lowered to 28674, and the root has been lowered to 24,578. Come back over here to switch 2, show spanning tree for VLAN 2. We see here that the root is now 24,578. As kind of a test, let's copy this here. 24,578. Spanning tree, VLAN 2, priority 24,578. Or 576, remember, because of the VLAN ID. Do show spanning tree for VLAN 2. Now you're going to notice this bridge has become the root. So let's do show run spanning tree. You'll see here once again, spanning tree VLAN 2 priority. Show spanning tree for VLAN 2. And you're going to notice that it is not the root anymore. Now this might just be an issue with the software and the emulation that we're using right now, but switch 2 should automatically adjust its bridge priority in order to become the root. So you're going to see here that it said spanning tree VLAN 2 priority. If we go back in and try this configuration command again, root primary, do show spanning tree for VLAN 2. Now you're going to notice that switch 2 lowered its bridge priority all over again. Show run section spanning tree, and you'll see that it has lowered and has now been made the root for VLAN 2. So I know that was pretty quick, but it's a nice little intro to how switching really works. We have to worry about our neighbors for show CDP, which is the Cisco Discovery Protocol, and how we connect to all these separate devices. We have to look at the VLANs configured, if they're access ports or trunk ports, as well as which VLANs are allowed across the trunk ports and are forwarding and not pruned. Lastly, of course, we have to verify our spanning tree instances to make sure the switches we want to be root will be root. There is a lot more to this, of course, when we talk about IEEE spanning tree, rapid spanning tree, and at some point we'll also talk about multiple spanning tree. Also, in case if you were wondering, this is the same type of options you'll be able to get with the NTRAS subscription. If you want to have connectivity between 2, 3, or 4 switches, so you can learn switching, whether it be layer 2 or layer 3 devices, or if you want to have even more devices, or if you want to learn about routing between routers and switches, etc., we can also specify the Cisco routers as well. So I hope you enjoyed this video. We'll be following up with probably a presentation on some layer 3 routing between switches and routers in our next video. Hope you can stay tuned for that.